Okay, Shakira, so this is, you were a little bit behind, so we're now on the Monday assignment for Mr. Little's class. You're factoring a GCF, which is exactly what we were doing with the dividing stuff, so it really shouldn't be sort of a new concept.
GPS signal lost.
Sorry, shouldn't be a new concept, but I'm just going to do some of these examples with you. So remember, common factor means that you're taking out something that they both of those terms have in common. So common factor between 21 and 28, the greatest common factor would be 7, right? Because 7 is a factor of both of those. It's the greatest factor between both of those. So I'm going to take out a 7, and then, so the difference here being that I can also, since they both have an x as a factor, that is also a common factor because the x is a factor. So whatever this number represents, that same number is over here. So they share that in common. So I can take out an x as well. I can only take out 1 because that's the lowest amount that I can take out from here. Okay, so you're always going to take out the lowest exponent that you have. So this is an exponent of 1, so I'm only taking out 1x. Okay, so I'm taking out x to the first power. And in here is going to be what's left over once I take out this 7x. Right, so let me focus this. So if I take out 7x from 21x to the fourth, 21 divided by 7, that's 3. Let me try to put it right on there, see if that'll help. I don't think that's going to help. But maybe slightly. I think I put it down here. That looks better. Okay, so I take out 7. That leaves me with 3, because 21 divided by 7 is 3. And if I took out an x from the x to the fourth, that would leave me with x cubed, right? I have 3 left over. This is a positive number, so that means that this factor is going to have to be negative. If I take a 7 out of 28, that's going to leave me with 4, so negative 4. And then I took out the x, and that's all it had. It only had 1x. So I'm just going to leave that exactly like that. So that would be my factored polynomial here, if I take out GCF. Okay, let's do another one. So let's do one like number 8. So this has 3 numbers, but that's okay. I can still take out a GCF from all of them. So let's think of some factors of 24 that might be common with 18 and 27. So 7 is not one. 8 is a possible, but 18 is not a multiple of 8. 4 is not a possibility. 9 is not a possibility. Let's see. 3 times 6. I think the greatest common factor between all of these would be 3. So let's try that. So I'm going to put a 3 out here. And I can't take a k because this one doesn't have a k that I can take. So the k's will just stay the same. So if I factor a 3 out, this is going to end up being negative 8. And this will k to the fourth because I didn't take out any k's. And then this will be negative 6k. And this will be 9. And I know that that is the greatest common factor because between 8, 6, and 9 there is not a common factor. So I know that that is correct. But if I did find that there was a common factor between these, I would just do it again. Okay, so let's try to find another one. Let's try to do one with that has several variables. So we'll do one like 17. So common factor between 35, 20, and 10, I would have to say is probably 5. So I'm going to put here 5. Whoops. Let me rewrite that. Okay, so 5 is part of it. And then if you notice, we have all 3 of the terms have a's. So I'm going to take the a that has the smallest exponent, because that's the smallest number that I can take. Because I can't take any more a's from this other than a to the 5th. Because beyond that, it's not common anymore. So all of these have at least 5 a's in it. Right? So I can take out 5 a's. So I'm going to take out the 5 with the a to the 5th. And this is the only one that has a b, so I can't take out a b. It's got to be common between all 3. So I'm just going to now figure out what goes here, right? 5a to the 5th times what gives me negative 35a to the 5th. Okay, so 5 times what gives me negative 35? That would be negative 7. And I don't put any a's because that's exactly how much is here. 5 times 4 would be 20. And then to make up the difference here, if I contribute 5 a's, I would need at least, well, not at least, I need 4 more to make exactly 9. So this would be a to the 4th. And that's going back to your exponent rules of adding exponents when you're multiplying them with a common base. And then from here, 5 times what gives me negative 10? That would be negative 2. And then for my a's, if they already have 5, I got to make up the difference here, so that would be a to the 3rd. And then b to the 3rd, because we didn't have any other b's, so we have to just put that, tack that on the end there. And that's the answer for that one. Okay, so there's that. And let me think here. Let's go ahead and I'll do number 23. So we have between 12 and 15, obviously it's a 3, it's a common factor, and then there's a common u, because this only has one u, so you can only do that, and the v, this doesn't have a v, so I can't take out a v, so it's just 3u that I can take out. That's my greatest common factor. So 3u times 4u squared will give me 12u cubed, and 3u times positive 5v would give me 15uv, because the u is going to be contributed and the v wasn't able to be taken out, so it had to be placed there as well. Okay, so this would end up being this, no, would end up being A. Okay, so you should be able to do that on your own. Try your best. If you have any questions, I will address them when I get back. Okay, thank you.